Video we are going to solve a few more numericals based on electric field strength. Okay, so we are going to solve some numericals based on electric field strength. Okay, and remember this is for the Ibdp physics course. Okay, and the chapter name is electric and magnetic field. Electric and magnetic fields. Okay. Okay. So let us do this numerical. The numerical says that calculate the electric field strength in a vacuum. So they are mentioning you that it is in a vacuum. A 1.5 centimeter from a plus 10 microcoulomb charge. B 2.5 meter from a negative 0.85 millicoulomb charge. Okay, so this is the numerical that you are going to solve today. So basically he has asked you to find out the electric field strength, okay, and in vacuum. So the medium is vacuum and you have to find out the electric field strength. So let us start the solution for the A1 first. According to the question, a charge of plus Q, which is equal to 10 microcoulomb, is somewhere placed in the space, and because of this charge there is a electric field created, and you have to measure the electric field strength of this particular electric field due to this particular charge at a distance of say 1.5 centimeter. Let that point P be at a distance of say 1.5 centimeter. So at this point P, okay, at this point P, you have to find out the electrostatic field strength, EP. Okay, this is the question A. So the formula for EP will be, it's a vector quantity, right? The formula will be equal to K multiplied by Q. This Q is the charge due to which the field has been created. So that is Q divided by R square. This is the formula. Okay. And K is a Coulomb's constant and its value for vacuum, because here the medium is vacuum. So the value for K will be 9 times 10 raised to 9 into Q is 10 microcoulomb. Now when we want to do calculations, we have to always show our charge in coulombs and distance in meters to follow the SI system. Okay, so this being 10 microcoulomb, I'll multiply this 10 into 10 raised to minus 6. So this will make it coulomb, because 1 microcoulomb is equal to 10 raised to minus 6 coulomb. Okay, so 10 into 10 raised to minus 6, whole thing divided by R square. Now R is what? The distance between the point and the charge. It's 1.5 centimeter. So in meters, 1.5 centimeter will be 0.015 meters, right? So I'll take this as 0.015 whole square, right? So let us do the calculation. Now this will be 9 times, this is 10 raised to 9, this is 10 raised to 1, so 9 plus 1 is 10, and this is 10 raised to minus 6, so 10 minus 6 is 4. Okay, 9 plus 1, 10, 10 minus 6, 4. So this will be 10 raised to 4, 9 into 10 raised to 4, divided by 0.015 the whole square. Now this 0.015 the whole square I can nicely write as 15 upon 1000 whole square, which I can again write it as 15 square is 225, and this 1000 square will be 10 raised to 6. So this can be written as 225 into 10 raised to minus 6, right? So this square 0.015 square can be written as 225 into 10 raised to minus 6. This will work out to 9 upon 225, okay, and 9 upon 225 should work out to, okay, let us see. I'll have to use my calculator, and this quantity 9 divided by 225, it works out to 0.04. Okay, this quantity, it works out to 0.04 multiplied by, this is 10 raised to 4 and this is 10 raised to minus 6. So this 10 raised to minus 6, if it goes in the numerator, it will become plus 6. Okay, so 10 raised to 4 into 10 raised to 6 will be 10 raised to 10. So this is your answer for the EP. Now if I want to write it in the scientific notation form, okay, let me write this as 4 into, now because if I want to make this 4, I'll multiply by 100. Okay, so if I want to multiply by 100, I'll have to divide also by 100. So 10 raised to 10 upon 100 will be 10 raised to 10 minus 2 will be 8. Okay, so the answer will be 4 into 10 raised to 8, and EP, the unit is Newton per second. Okay, so this is the answer for your magnitude of the electric field at this point P. Now direction will be what? Now see, this is a positive charge. Okay, so from a positive charge, the electric field always goes radially outwards. Okay, it goes radially outwards. So at this point, the electric field will have this direction. Okay, radially outwards. So the direction of the electric field strength at P will be radially away from the charge plus Q, okay, along the line joining QP. Okay, so it will be in this direction, right? So that was A part of the question. Now B part of the question is similar, only the values have been changed. So for the B part, the charge now is not a positive, it's a negative, and its value is given to you as 0.85 millicoulombs. MC means millicoulomb. Now at this point, say P, okay, you have to find out the electric field strength, EP, right? And this particular point is at a distance of 2.5 meters now. Okay, so R is equal to 2.5. Okay, so again let us start working. So electrostatic field strength EP at the point P, EP is equal to K, because it is in vacuum, K will be 9 into 10 raised to 9. So K multiplied by the charge which is responsible, so it is negative 0.85, and this is millicoulomb, so I'll convert it into coulomb. So milli means 10 raised to minus 3. So 0.85 millicoulomb is equal to 0.85 into 10 raised to minus 3 coulombs. So I have taken the charge in coulombs. Okay, so it's very important that the charge should be in coulombs and the distance should be in meters. Here the distance is already in meter, so I am going to divide it by 2.5 the whole square, because distance is already in meter, so no conversion needed. Okay, so okay, so this is the thing. Okay, so EP will be equal to K value, you can take very nicely as 9 into 10 raised to 9, because it is a vacuum, the medium is vacuum, multiplied by negative, this is the type of the charge, it's a negative charge, so this is 0.85. So can I write this 0.85 as 85 into 10 raised to minus 2. Okay, you can convert it, right? 0.85 can be written as 85 into 10 raised to minus 2, 85 upon 100, right? Into 10 raised to minus 3, that is this, divided by 2.5 square. 2.5 square will be 6.25. Okay, so our answer will be this negative sign. Well, let me bring it over here. Okay, now this is 9 times 85. Sign I am keeping outside. So 9 times 85, and this is 9, 10 raised to 9, and 9 minus 2 is 7, and 7 minus 3 is 4. So this will be 10 raised to 4. Okay, divided by 6.25. So my answer will be, negative sign will always be there. Now 9 into 85 divided by 6.25. Let me try this. So this works out to 9 into 85 divided by 6.25, and this works out for me to 122.4. Okay, only this quantity multiplied by 10 raised to 4 you already have, isn't it? So this will be equal to now if I want to make it in the scientific notation form, minus sign will always be there. Now I will bring this decimal over here, so I'll make it 1.2. Okay, so to make it 1.2, I'll have to shift the decimal 2 to the left. Okay, so for doing that, I'll have to multiply here by 10 raised to 2. So that will make it 10 raised to 4 into 10 raised to 2 means 10 raised to 6. Okay, so just converting this into scientific notation form, this becomes minus 1.2 into 10 raised to 6, and the unit is Newton per coulomb. This is the magnitude of the electric field strength. And what will be the direction? Now for a negative charge, okay, the electric field is always directed inwards towards the charge. So here also the electric field, this EP, will be directed inwards towards the charge. So the direction of EP, the electric field strength, is inwards towards the charge. Okay, which charge? This charge. Okay, towards the negative charge Q along this particular line joining PQ. Along the line joining PQ. Okay, so it will be in this direction, inwards. So that's about this particular question. So it had two parts in it, A and B. For A, it was to find the electric field strength at a point which is 1.5 centimeter from a charge which was 10 microcoulomb. That was this question. And B part of the question was you have to find the electric field strength due to this particular negative charge, 0.85 millicoulomb charge. Okay, and at which point you have to find? At a point which is 2.5 meter away from the charge. Okay, so for the B part, you have the answer as negative 1.2 into 10 raised to 6 Newton per coulomb. Okay, and direction for this particular electric field strength will be inwards. Okay, direction for the A part of the question will be radially outwards or radially away from the charge. Here it was radially inward towards the charge. Is that okay? So that is the numerical number 2 of this particular topic called electric field strength. It is also known as the intensity of the electric field. Okay, so whatever we have found out is nothing but electric field strength, or you can call it intensity of the electric field. Okay, that's all for today. See you in the next video. Bye.